So I'll provide you the case study
Okay.
between a Scala and Python. Which language we should select for the project based on your business profile, correct? That is
Okay.
the one use case. And this will help you basically to understand in and out, okay, this
Yeah.
study. So I'll provide you on 2 hours of recordings along with the documents here. And then we can discuss next class based on your questions here. That is your self-learning.
Okay.
Now I'm coming to fundamental of Scala. The first of all, exactly as we know, right? Whenever we learn C, so we say what is C? Java. What is Java? What is Python? Same questions I'm asking you. What is a Scala?
Programming
From
language. Functional
okay,
programming.
yeah, that is okay, fine. So point is that two questions I'll be adding you. Sorry. See, we have a C programming language, correct?
Yes.
Then Java,
Yeah.
then C hash, then Python. And now what we are talking? We are talking about a Scala,
Scala.
right?
Yes.
So you can see here C and C++ history was almost 90-80 onwards are being used C and C++, correct?
Yes.
The history 90-80. It might be before 90-80 also. Just I'm keeping one time frame, okay? Onwards. Java, it was from 1992. This is from 1992. Python also was used from 1980. It was there in the market. Okay.
Okay.
C++, C has comes after Java, Microsoft product, right? .NET.
Yeah.
So it might be, let's say it come by 1996. But a Scala you can see in the market, it was also there in the market basically 2010. Okay.
Okay.
It was there in the market 2010. But after a spark, it picks the market, right? 2014. So you can see here, it means Scala is the latest programming language in this market, right?
Yes.
It is not too old. But if you compare to other programming languages, those are already old, right? So what happened basically, why this Scala has replaced other programming language? The idea behind this, it has many features that we are going to discuss right now. So the first point we say exactly, just first point, okay? The first feature of Scala. I'll send you my details notes, okay, for your study
Okay.
also.
Yeah.
So the first point we say basically a Scala is 100% object-oriented programming language. I'll come to my next class about class and object, not today, okay?
Yeah.
Programming language. So what do you mean about this? What is the meaning of 100%? Why this is known as 100% object-oriented programming language? Any idea? So
No.
100%, it's okay. 100% means I'll help you. 100% means we can say everything is either class or object. You got my point?
Okay.
Suppose I am declaring one class hello is a class. Now I'm going to declare one variables. The var
Yes.
a is equal to 10. So this will be like this in a Scala, correct? You know already. So what is a and hello is a class. This is the class name, and this is object of type integer. So a Scala basically you can see this is the object of the class. So this is, we can say, object A of type int class. we cannot say basically a is a variable here. Of course, we are using as a variable because we have habit, right? C, C++, Java, C Sharp,
Yeah.
Python, we are using full word, right? But logically, it is not a variable. It is just one object of type integer class. Clear now? You got the point?
Yeah.
Now, this is the class name. So the meaning is that exactly whatever we are going to write inside this class, either it is a class or object. Nothing is beyond that. Okay, so that is the reasons Scala is a completely 100% object-oriented programming language. Is the one features what it has. So second point is that you can see here basically it is known as parallel programming language. Okay, so parallel programming language, why it is known as, because it has been designed using massive parallel processing algorithm. Okay,
Yeah.
they use this algorithm to design this language. So what do you mean about parallel programming language? Can you explain me?
Parallel processing in the sense multiple programs are run at a time, the same time, parallel.
Correct. So the idea behind this basically can see nowadays we work on big data world. So big data means we are talking about multiple node cluster, correct? Not single node machine. So if you see here, if I have a 5 node of cluster, 5 node cluster, we are talking about the Spark, we are talking about the we are talking about right now a Spark, right? Because a Spark is developed into a Scala. So if it is a 5 node cluster, if you are going to submit the job, what happened? It has to parallelly process the data to all the node, right? At the
Yes.
same time. So if it now if we compare two algorithm, okay, here
Yeah.
before going to this is very important for us. Map reducer. Have you heard about map reducer algorithm?
Yes.
Okay. So MapReduce algorithm was used in Hadoop, right?
Yes.
It is used. No, I cannot say was algorithm. It is an algorithm. Okay, it is not a program. It is not a tool. So it algorithm used in Hadoop or Hive. You got the point? So
Yes.
this MapReduce algorithm also used to compute your data parallelly. Okay, I'm not denying. Now, if the MapReduce is there, then again, then why we are going for the Scala?
Scala. Yeah.
Already Hadoop has the MapReduce. Hive also has the MapReduce, but it and this MapReduce supports your MPP, massive parallel processing algorithm technique internally. So what happened basically in the MapReduce algorithm? This algorithm was developed using the Java. As a developer, I should know Java.
Yes.
I should be good in Java, and we
Yes.
required like lots of lines of coding. Okay, so
Okay.
I'm if I'm writing like 100 lines of code in Java, in a Scala I should write only 10 lines of code. 19 lines gone, right? The lines of coding has been concise in the Scala than the Java. Is the one. Okay, and
Okay.
Java is a legacy programming language now, right? Not like a
Yeah.
Scala, correct?
Yeah.
So it's a very old. Right? Java is like 1992. So there is no much performance wise has been improved, right?
Yes.
So Java does not support your parallel programming language. Okay, MapReduce algorithm is doing the parallel processing, but as it has been developed in Java, the performance is not good. You got my point?
Got it. Yeah.
For this algorithm, I'm talking about algorithm, right? Not the technology.
Yeah.
This algorithm was designed in the consideration to compute your large amount of data, the big data, right? If you have
Yes.
1 terabyte data, petabyte data, zettabyte data, can we compute using the MapReduce? No. If we have a 1 GB, 5 GB, 100 GB, 1000 GB, not 1000 GB, I cannot recommend. Yes, we can use MapReduce or Hive. So that is the reasons slowly Hive also gone from the market. It also been outdated. Okay. The
Yeah.
reason is that this Hive is dependency on what MapReduce to compute the data and Hadoop, right?
Yes.
For the company. Second point is that to perform this, to improve the performance optimizations for the Hive, we use some other approach, right? Alternate approach we are going to use, not like a MapReduce, right?
Yeah.
Alternate approach we use nowadays, right? Optimizations to
Mm.
to optimize in Hive. That will discuss my Hive class, okay?
Yeah.
So that was the history of MapReduce. So MapReduce algorithm is an algorithm which has been written using the Java programming language, which is used for Hadoop or Hive computations. But as MapReduce has been developed in Java, which does not have the high computing performance, basically it is slow. Okay, the
Mm.
computing process is slow. So
Yeah.
whatever the expectation was there, that has not been achieved in the MapReduce. That is the reasons now the MapReduce become gone outdated from the market due to a Spark, right?
Yeah.
So when a Spark comes to the market by 2014, right, or 15, not 14, I can say exactly the 16. Okay, the Spark is 16 started. Okay,
Yeah.
when came to the market, right, now the performance improve here. Basically we can say by 10x, not 10x, 100 times than the MapReduce.
Yeah.
You got the point here, the
Yeah.
alternate. So why this performance has gone improve in a Spark? Of course, computing part and all we'll discuss in coming classes. The
Yeah.
one of the reason was there, the Spark has been developed using a Scala.
Okay.
You got the point here,
Yeah.
the bottom line. So one of the major reason was there, a Spark has been developed using what? A Scala, and a Scala supports parallel programming language, right? Massive parallel processing technique internally has been used in a Scala. So that is the reasons it has better performance than any programming language in the market. Is
Got.
the one solution. So that's why this Spark was designed or developed using what? A Scala. Even currently, okay, you can see if suppose I'm writing the PySpark code, okay, I'm writing PySpark code or a Spark SQL, suppose, right?
Yeah.
A Spark SQL. What it does exactly in the background, whenever we are going to run, right, this code, it first it convert into a Scala.
Okay.
In backend, convert into a Scala and then process. See that?
Okay.
Okay. So if even you're talking about Databricks notebook, PySpark, either Azure Synapse, I'm talking you, Databricks, I'm saying normal PySpark, I'm talking normal Spark SQL, I'm saying. So what happen, like whenever you get any like at runtime, you can see the script has been converted into the Scala and then it is processing. So it means what? Down the line, backend is Scala, correct?
Scala. Yeah.
Okay. So that
Mm.
is the one point here we are talking. So massive parallel processing algorithm, it's a one algorithm, okay?
Yeah.
So this algorithm basically has been developed, used in a Scala, okay, and developed in a Scala basically, MPP algorithm. So which improves your performance of your programming language. And that is the reasons we say a Scala is a parallel programming language. It means it can compute your data parallelly to multiple node of clusters Even it is large amount of data, no matter. Next point we say exactly, Scala is a legacy programming language. So it has many names, okay? Legacy programming language. See? So why Scala is known as legacy programming language? Any idea? So I'll
Because
tell
it is
you,
an
no
object
problem.
oriented
So a
like Java.
Spark was no, I'll tell you. A
Yeah,
Spark was developed using a Scala programming language. That is clear.
correct.
And
Yes.
one of the major features exactly for the Scala has been adopted in a Spark is legacy. Here, see that my pointer. Okay, a
Okay.
Spark was developed using a Scala, and one of the primary features has been adopted by the Spark is what legacy system. So legacy means what? The question is that. So let's understand here.
Yeah.
If I am writing one program in Java or Python or C and C++, what happened? Suppose one function has 100 of function, right?
Yeah.
1, 2, 100 function, okay?
Yeah.
What will happen? All this function has to be compile and compute, right?
Yes.
I'm talking about other programming language.
Yeah.
Okay, it is going to compute all this programming language, right? All these functions, right? Even
Yes.
either you are used or not. Let's say sale, retail. What happened? Customer, sales, shopping, right? Return, payment. So many functions we have to develop.
Yes.
But if you talk about the retail, if it is customer, sales, shopping, transaction, payment, okay, return item, quality feedback, customer feedback. So in that case, what will happen? But at the time, I required only the customer feedback information. I don't want any other information as a being customer, right? I want to check the customer feedback. What to do? So as per the legacy programming language, either you're talking about C++, Java, C Sharp, Python, what it will do, it computes all the functions one go, and then we are going to call the corresponding method. But in Scala, it does not happen. What it will do, it keeps all the functions in the memory. It will only compute the functions on demand.
Okay.
So if I'm demanding only the customer feedback, it is going to compute only customer feedback functions for my requirement. The rest of the functions will not be computed at all. Legacy means sleeping mode, right?
Yes.
Okay. So legacy means sleeping modes. So what is the advantage of that? Suppose if there are the 100 functions, but one customer is calling only one function, customer feedback. So it means 99 functions are not being used by the customer.
Got it.
Am I
Yeah.
right here?
Yes.
So we are saving lots of memory and computations processing also here. Compute the data which is required by the customer. Don't compute which is not required by the customer. Okay. So
Yeah.
due to this legacy system features, Scala got adopted by the Spark. So it saves computations and memory also both. And it computes only what we required here, right?
Yeah.
It computes what required. That's all. So that is the reasons we say Scala is a legacy programming language. It is not going to compute all the functions in one go. It will only compute the functions which we required on demand, basically. Okay.
Yeah.
So that is one of the major features of Scala has been adopted by the Spark. So we discuss object-oriented programming language because everything is class and object in Scala. Nothing is beyond that. Okay, it is a parallel programming language because it
Right.
is the programming language which supports to compute your data parallelly to the multiple node of cluster. Okay, let me tell you one example. Okay, one use case of a Scala first. Core Scala. So let's take one example here. Metro train. Okay,
Yeah.
have you heard, right?
Yes.
We know now metro train is common in India also.
Yeah.
Metro train is a system programming or big data programming
Big
or
data.
both? What will be the answer?
Big data.
Big data plus system, both, right? So in the metro train, we are using big data. Yes, I agree. Because data is keep on generating every second because train is moving, right? And
Yeah.
plus we are doing what? System programming. Okay. Or to corresponding metro station. You got my point here?
Yes.
Okay. So I'm just taking the two example here. One is to send the signal to other to nearest station. For that we require the system programming, and I want to broadcast the arrival and departure details of the corresponding stations or departure details to corresponding metro station, right? So you can see here right now this metro train how it works. Let's imagine first use case. So metro train project has been developed using a Scala first of all. Okay, in
Okay.
Germany. After that, it has been used Japan and India and other country. Okay, so they move from Java to a Scala. It was initially Java. Now they have moved to the Scala. Now means before five, not five. I think 8 9 years. So let's understand. So let's see here. If I have one metro stations one, I have a metro stations two, I have metro station three, I have metro stations four. All are different metro stations, right?
Yeah.
Okay. So here point is that exactly, and this is the one city, one area. Let's say like from Bangalore Hebal to we can say right now like ITPL one row or Whiteville, correct? Hebal to let's say. Now point is that here, if the metro station is here, let's say your metro train is here on this station, okay, and this is nothing but like Nagwara. Imagine, right? Nagwara station
Yeah.
in Bangalore. Now, this train has to send the signal if this train is going to this direction or this directions depends, right?
Yes.
Okay. So anyway, either arriving or departures or some of the trains are here. Let's say some other trains is in Whitefield here. So this train also has to come to this next station, and some train is here. Some train is here, right? Let's see here. Correct? It
Yeah.
can be or not.
Yes.
It can be, right? Many trains will be coming and going, right? Every 2 minutes, correct?
Yes. Yes.
Like that, there may be one more train here. Let's say I'm keeping one more train here. Now you will understand the flow. So what is you can see the two train is going in one direction, two train is going to the opposite direction, correct?
Yes.
Now the point is that why we adopted the Scala. Okay. The first point you can see here right now, in this the stations number one, let's say this is the two, this is the third station, this is the fourth station, this is the fifth station, and this is the sixth station, right? There are the six metro stations. So
Yeah.
the first station sending the signal to the nearest stations, correct?
Yeah.
I'll be arriving 8:36 a.m. Fine, 8:36 a.m.
Yeah.
The first, this is sending signal. Similarly, this train is also sending signal here to station number 2. I am arriving 8:37 a.m. You got my point?
Yeah.
Now let's say here, so what is the difference here? 1
second.
minute, right?
1 minute. Yeah.
1 minute difference, correct?
Yes.
But due to some reasons, due to some technical fault or due to some programming delay or software delay, suppose these trains could not arrive 8:36, this train also arriving 8:37. What will happen? Because a station has a limited place, right?
Yes.
Stations cannot, metro station is not like railway platform which has 10 platform, right?
Platforms.
Hardly it
Yeah.
has two platform, correct? You got
Yes.
the point here?
Yeah.
Now, so in these cases, there will be conflictions or there will be chances of to being some kind of accident also due to some delay of 1 second also. Okay. So that is the reasons they adopted the Scala programming language where there should not be delay due to any technical issues. Software issue I'm talking you. So in these cases, this will be sending the signal to all the station the same time, right? Same
Yes.
time. So that exactly the decision making persons they knows exactly what our customer knows, right? What time the train is coming, that is being displayed, right? The
Yes.
time.
Yeah.
That is the points. So the delay means if any delay happen, that is going to fault of your systems or network here. So that should not be happen any delay. So to overcome this problem, we adopted a Scala as a use case here, the system programming, and we support big data. Why big data? Because every second signals are being passed, right, in all the
Yes.
stations. This is the one code. Like that, Bangalore has hundreds kilometer of metro now, or Delhi has 300 kilometer of metro. So they are sending the signals around all the stations. How much data we are capturing internally, right?
Yes.
And we have to track and restore the data as a big data. Why we need to track to perform the analytics? What analytics? Which train was on always time 24/7 in the last 30 days? Which trains got delay? What is the root cause for delay? Correct?
Yes.
We need to find in the backend to improve the technology, to improve the system. It is not like that. We live like a normal railway station, correct? In India.
Yeah.
So we have to perform it. It is completely digitalized. It's end to end in the metro. And that is the reasons we are adopting what big data to perform the analytics and a Scala using here to send the signals and broadcast arrival departures without any delay to all the corresponding stations with reference to the corresponding train, we can say metro train, correct?
Yeah.
So this is the one of the use case we use what a Scala, the best use case.
Good.
And now, so what is the advantage? Why they did it? Now the point is that, right? So the reason is that this has been parallelly sending data to all
Yeah.
the network, correct?
Yes.
Correct.
Yes.
This train is sending parallelly to all the station, correct?
Stations. Yes.
So every station is nothing but the one node for us, right? One cluster
Yes.
node.
Yes.
Every station is one node. They have also they will have some system to capture the information, then publish to the time board or display board, right? Okay, on the server. So similarly, like here, parallelly it is sending the data to you. Second is that one more point we say uh, this system, right? Scala. So first of all, a Scala not only it is used for the big data, it can be used for the system programming, mobile coding also, web programming also. Okay, security also nowadays. So that's why a Scala nowadays widely are being used not only the big data in the system programming. So it is a kind of replacement like C++, right? If you know, right, C++ programming language was used for the system programming. So nowadays we recommend a Scala than C++. Okay.
Yeah.
So because of this parallelism, right? So what is happening here? So it is basically improving the performance, right?
Performance. Yes.
Correct. The major factor is what? Improve the performance, and that is the use by the big data. Correct.
Yes.
Improve performance. So that is the advantage of what? Parallel
Parallel
programming.
programming.
Okay. Next point is that here in the same example, concurrent programming. See, so concurrent programming means one train is sent, like suppose let's take an example. One train from number 6 is sending the informations to all the stations 5, 4, 3, 2, 1. Correct?
Yeah.
Okay. So that the two terms always used in the programming world. Okay. So a Scala also known as concurrent programming language. Okay. Concurrent programming language. And it is also known as what? Parallel programming. Correct? Just now we discussed. Correct?
Yes.
Okay. Legacy programming language. Object oriented programming language. Okay. So what do you mean about concurrent programming language?
Concurrency is also something similar to parallel programming, right?
Similar agree. So what happened concurrent programming language, basically it works on multiple threading concept technique. Okay, it applies the multi-threading concept. Okay, multi-thread concept. Okay, thread technique. That is the difference here. So in multi-thread technique, what it does exactly, suppose 6 number station, correct?
Yeah.
Here it has some processor of i7. Okay, and it is using, let's say, like 12 GB of memory, correct? So
Okay.
this entire system, like the entire computing processing, right? The infra details what I'm talking about. It will be used by all the thread. So what it does exactly here, it creates thread number 1, thread number 2, or thread number n. I don't know. That depends on the input. Okay. So
Okay.
what is the multi-threading? I'll tell you. The multi-threading concepts came in Java. Multi-thread means dynamically it allocates one amount of memory and processing engines, or we can say like processor, right? We say, correct? Okay,
Yeah.
to
Yeah.
execute program. But multi-threading means it will be working like sequentially manner. Like suppose one thread will go, then second thread and fourth thread parallelly. It won't go.
Okay.
Concurrent programming means sequentially. Parallel programming means parallelly.
Okay.
You got the point. But what is the advantage of concurrent programming also? It is going to be use share same infra or same memories or computing processing for all the thread. Otherwise, what happened? Suppose i7 12 GB we have. Now we have 3 thread. So it does not allocate any special memory for the thread. Okay, it is a virtual system. Virtually, it allocates the memory, it process, and it destroys itself. So that's the point basically here. What is the concurrent is coming here? So concurrent programming means suppose if you have the 2 threads, okay, so it is going to execute concurrently one by one. First thread 1, then thread 2, then followed by thread n. You got my point here? So
Yeah.
concurrent means sequentially it will compute the data like 1, it will go to the 2, and then it will compute the 3. Like that it will be there. Okay. So the even this also feature supported by the Scala.
Scala.
Next is that here a Scala is the types. Let's go to the system. Okay, let's see some of the example here. Okay, so if I'm giving it the var a is equal to 10, and if I go to another terminal, if I type here Python 3 and a is equal to 10, what is the difference between both? Dhiren, what is the difference between both?
It's here we are defining a variable and then providing the value.
Okay.
The Python, I think we have not defined the data type of that. By default, it based on the value, it understands the data type.
See, both are almost same. Python also it is a is nothing but now integer type because based on the value, correct?
Yes.
In a Scala also based on the value, it has taken a as an integer type, correct?
Integer. Yes.
But the difference is that now a can be 22.22, but here this cannot be 22.22. See that? Now I can say a is equal to print a value is what?
22.22.
Again, if I make here a is equal to string, again if I print a is equal to what? Hello, correct?
Yes.
But can we do in a Scala? No. See that? Type mismatch.
I mean, that means we cannot change the value of a variable in Scala. I mean, it becomes like a constant.
Not constant. Okay. You think and tell me the answer. Think. I'm typing, okay? I need answer from you only. So
Yeah.
it got changed, right? Now you tell me the answer. Screen it is there with you now. Any guess? See, a Scala, whenever the first time, let's go with the Python, okay? In the Python, if you're giving a is equal to 10, now the value is going to change double and a string, correct?
Yes.
So it means the value can be modified anytime. Even not only the value, even data type also, correct? It is
Yes.
integer, it is double, it is string. But you can see in a Scala, once we declare the variable or type a is nothing but object of integer class, correct? Na?
Yes.
What is a? A is the object of what? Integer.
Integer.
It means the behavior of a always should be the type of what?
Integer.
Integer. Agree? The behavior of a object always should be type of integer now onwards. The behavior of the object cannot be changed. Let's take an example. Suppose you are working for your company Visa, right? I work for IBM. We cannot switch our company. Can we switch?
No.
No, till we don't join the company, correct? That is
Yes.
that is another case. But ideally, we cannot switch the company on the daily basis, right? We cannot tell I'm in BJ, I cannot tell you I'm in IBM, right?
Yes.
So that terminology is known as type safety. So a Scala provides the type safety programming language. You got my point here?
Yeah.
So you see that here. Now a is equal to 22.22. So what is happening here? It is saying type mismatch. Why? because we are trying to assign some another class variable object, sorry, value, object double. This is the double value, right?
Yes.
So it means this A should be or must be a type of double object of double class, we can say, correct?
Yeah.
But what is this? But
It is
this A is an object of type what?
integer.
Integer class, not a double class. That is the reasons we are getting error type mismatch. Similarly, here hello. If you are trying to assign to the hello to A, it means A must be the type of string, correct?
Yes.
But A is an object of what? Integer. That is the reasons it is saying type mismatch. But when we assign 13 to A, so 13 is an integer and A is an object of what? Integer class. That's why it is valid now. So it means what? The value can be changed of the object, but that value must be the type of the same class, correct?
Same class. Yeah.
Okay. If you're trying to assign other class or other data type values, that is not possible in a Scala. So type safety programming language. That is the points what we say. This is the biggest drawback in Python, right?
Okay.
Okay. If you study my, you'll go through my recording, what I have done the case use case study, right? For
Yeah.
one company, you'll have more details. Okay.
Okay.
Right now, so in that cases, we understood here this is the type safety, right? So
Yes.
Scala is also provide what type safety programming language, correct? See, so many programming languages, are, right? Type safety. Okay, easy we discuss. Next is that.
But
Uh, yeah,
no, no. But this casting is available, is it? I mean, sometimes it happens, right? Like if we have a date format, then we need to convert it into another format, and so that kind of flexibility is there in Scala, is it?
yeah, casting is there. Casting is the different, but that is the different case. That means you are forcefully casting, right? Suppose
Correct.
I'll take you an example. Bank interest rate. Bank interest rate is what? Double, right?
Yes.
See, the
Yes.
VAT, let's say I'll say here, loan, personal loan interest rate. Okay, it should be always something double one, right?
Yes.
Can we make a string this one? Should we require a string? No, right? Should
No.
we require
No.
integer? No, correct?
No. No.
So there are the lots of variables where type casting is not required. It is mandated to be the similar kind of data, right? Like credit card number. Can we change the type of credit card number?
No.
Account number?
No.
No, right? So in that case, which language is better? Scala. It won't allow, right, to the customer.
Okay.
But the account number can be changed. But type of account number cannot be changed, correct?
Okay.
Suppose I got one bank account number. I'll go and request to the bank, please change me account number, correct? I don't want this account number. I want some VIP number. Is it possible or not?
Possible.
Yeah, they charge money for that. For VIP number means it's charged. I suppose I want 100000011, right?
Correct.
Like mobile number. Simple example. Here and here. I have
Yeah.
one number 8904000040. I have taken this number before 15 years. Okay. To get this number today, you have to pay minimum 1 lakh rupees. So number can be changed, but not the type of the number can be changed. Correct.
Yeah.
So it means if I have written this mobile number in the Python language, what will happen? Tell me now. If it is in Python, what will happen? What will happen? Type can be changed. Anyone can modify your data, right?
Yes.
So rather than this number, it can be what? String, it can be double, it can be any, right?
Yes.
So that is the one of the drawback in Python. Okay.
Got it. Yeah.
So it has so lots of features. Type safety we discussed, concurrent. Any questions so far?
Good. Uh,
Yeah, if you have any questions, please let me know. Any silly questions, always welcome for me.
Only thing is, when we are saying it is both concurrent and parallel, is like I'm parallel programming. I understood with the example, but
Yeah,
again, when we are,
okay,
it
I
is
got the
both
point.
are opposite to each other, right? I mean,
Yeah,
parallel
yeah.
and concurrent.
Okay, okay. Wait.
Doubt on that.
Yeah, yeah. So I'll explain you the parallel and concurrenting, okay? Again. So parallel means you understood if you have like multi-node of clusters, parallel it will be sending the data to all the node, right? That is clear,
Yes.
right? There's
Yes.
no doubt into that. Okay.
Yes.
See, this is the parallel, correct?
Yes.
Now what is the concurrent? Same example.
Yeah.
Parallel plus concurrent, it works in, okay, the environment like this. Suppose here we have 1, 2, and 3. Same thing, right? So
Yes.
parallelly we are sending the task here. Parallelly we are sending the task here. Parallelly we are sending the task here.
Yes.
Let's say two customers is there. One is Dhiran, one is Amit. Okay, two customers.
Yeah.
How many customer?
Yeah.
Two customer.
Two.
So request to one and the request two, correct?
Yes.
Request two. Request one. So what will happen here? From this, and this is your master node. So in this case, the request has gone to all the node. Here also request one came. Here, Dhiran, one ID came, request one. Similarly, Amit, request two came. Correct now?
Yes.
So how many jobs has come to the one node now?
Two.
Two. Correct?
Yes.
Which job should complete first and which job should complete second? That is the concurrency.
Okay. Got
On
it.
the same node.
Got it.
Okay. Now, what will happen here? It will allocate the container as per
Yes.
the architecture, right? For each
Yes.
node. So
Yes.
let's say the container has assigned one and container has assigned one, correct? To compute the data. These all are the container on the same node here.
Yes.
Similarly, it will be here also.
Yes.
Here also will have the one container, two container. Like that, here also will have one container and two container, correct?
Yes.
These are the containers, not the node. Container means which has some of the resource, right?
Resources. Yeah.
Okay, resources, okay, to compute your data. So we will be getting default container right here
Yeah.
by the system. These are the container. Okay. So like that, if you have hundreds of customers are sending the request, it means hundreds of requests will be coming to the each node at the same time, right?
Yes.
So hundreds requests is the parallelly sending to the request. Okay.
Yes. Got
I'm
it.
not saying 100 requests will come to the one node. Might be if you divide
Yeah.
based on the configurations. If there's 100 users is sending the request, might be like if we have 20 worker node or data node or slab node. So five requests will go to the each node to compute the data. Let's imagine in that way. But anyhow, minimum two requests to be in one node.
Yes.
Two job has to perform.
Yes.
So which So to allocate, so for that we are getting container content. So this container is what? The containers are nothing but the resource of this machine, right?
Yes.
Internally, correct?
Yes.
So this, if suppose this task got completed, right? Sending response back to the your request. Again, this resource can be shared to the request too, right?
Yes. Got it.
to
Yeah.
compute faster here. So this
Yes.
process is a concurrency process
Concurrency. Got it. Yeah.
internally.
I got it. Okay.
Okay,
Mm.
multi-thread on one the same node. So that's why Scala supports concurrent model
Yeah.
also.
Got it.
Okay.
Yeah.
Now, Scala has some more features basically. So we say we'll be coming, we'll be learning also in upcoming classes. So I'm not
Okay.
focusing much here. So we say like it has like case class. Okay, it supports case class and pattern matching. Okay, so pattern matching will have the one lecture completely. So
Okay.
let me tell you about the pattern matching here. This is a pattern matching here. Suppose if you are going to the Google, correct? Every day
Yes.
we'll go
Yes.
and I'll say a Spark intro. What is this? A Spark intro? Now you tell me. What is this a Spark intro in Google?
It will give the exact, data which matches with exactly the Spark intro.
So no, you're going the very depth level. In the simple
Okay.
terms, in the layman, say exactly a
Yeah.
Spark intro is my input as a common man, a
Yeah.
layman in India, and I
Yeah.
want some of the information related to this, right? That is my requirement.
Yes. Yes.
Now, as a software engineer, I can say a Spark intro is one type of patterns, and based on this pattern, should return back similar pattern, right?
Right.
See, one is the layman, common man, who is not
Yes.
from IT background. They'll think, okay, enter a Spark intro, I should get some Spark intro details, right? That is done.
Yes.
As
Yes.
a software engineer, it is one pattern. I'm
Correct.
giving one pattern to the Google, and Google should return back to me similar kind of pattern.
Yes.
How it is happening in the background? Because they have used pattern matching algorithm internally in the Google. Google who introduces the first algorithm, okay, pattern matching algorithm.
Yeah.
You got the logic here?
Yes.
So, pattern matching development is much easier in a Scala than any other programming language. So that we'll discuss in you got my point about the pattern
Yes.
matching?
Yes.
High level, very high level.
Yes.
Okay. Case class means suppose I want to design some schema of my data. I have a department class. I have an employee class. I want to design what? Schema. My requirement, okay?
Yeah.
To design schema of the class. So we use case class. These are the topic, okay? We'll discuss and deep dive,
Yeah.
okay? Case
Yeah.
class, okay? Just I'm giving a very, very high level today, okay? Nothing more than that. Next is that it supports higher order function, okay? Is another advantage of the Scala. That is the reasons it is known as functional programming language, okay? And this is the reasons it is known as functional programming language. You got the point here? So because of higher order function, so Scala was the first language who introduces higher order functions, okay? So till JDK 11, these features was not available, okay? JDK 8, JDK 9, JDK 11. And this was killing the market completely because of higher order functions. So what is the higher order functions? In a simple terms, basically, suppose I have one function add, and in that I can pass another function what subtract also as a parameter. See that
Okay.
is a higher order function. So this add is a higher order function. So we'll discuss in function class. Okay.
Yeah.
Okay, got the point? Means
Yes.
functions can carry the function as a parameter. Till now we have seen we can pass only variable to the function, correct?
Variables.
C,
Yes.
C++,
Yeah.
Python, Java, right? Either you want to pass integer, you want to pass double, you want to pass string, all the variables value can be passed, but those to be type of variables only. But in a Scala, we got the features, the functions can pass another function also as a parameter. We can use, right? And
Yeah.
that concept higher order function. So these are the basic introduction exactly. So Scala has many more features than any other programming language, and currently it is being used widely in all every sector. Okay, it is not only the big data and all. So as I told, system programming, mobile programming also we can use. Security side we can use the Scala mainly use. Okay, I'm not saying web application. It can be used, but I have not seen. So, but mainly are being used system side nowadays a Scala widely used demand. And many open source softwares, not only that Spark, okay, all are coming into a Scala. Like
Okay.
I'll tell you, Kafka, okay,
Yeah.
Akka, a Spark, a Storm, okay. All these softwares have been developed using a Scala. Apache Storm, right?
Yeah.
And we have yeah, Apache Storm is this Spark. Akka is a framework, okay. This is widely used, okay, for Scala. It's a framework. Okay. Uh, let me go back. We'll discuss next basically how to create project in Scala. Okay, as in, let's go to the lab.
Okay.